All right, so like I said, we went through the first few of these yesterday, so we'll start down here, okay, with chlorine and sodium iodide and creating, or producing, sorry, not creating, iodine with sodium chloride. So I have an element, okay, reacting with an ionic compound, producing a different element and a different ionic compound. What kind of reaction is that? Single replacement. All right, so it's a single replacement reaction. Now we need to balance it. As a general rule, you go with something that is, first off, obviously not balanced and present in a large number. Chlorine will work for that choice. There are 2 chlorines on this side, but only how many over here? 1. So where do I put the 2? Right here. Okay, now that also gives me 2 sodiums. So I have to go back over here and put a 2 there. Does that make my iodines work now? Yes. Okay, so always a good sign you've done it right if things start to fall into place. All right, then we have to write it in words. Chlorine. Remember, just because this has a 2 after it doesn't mean it's not an element. Okay, it's still named as the element is named on your periodic table. Okay, it is one of the molecular elements. Plus sodium iodide. Okay, gives us iodine, same idea. Okay, plus sodium chloride. Questions on that one? Okay. For the one under it, what kind of reaction is that? We've got all ionic compounds all the way through. Double replacement. Okay, in a double replacement reaction, your general rule, swap the metals, right? And you can see here that now calcium was with chlorine on the reactant side, but it's with the other polyatomic ion carbonate on the other side. So they simply switch partners. So we have to balance. Okay, calcium looks like it's already balanced. Chlorine is not. So why don't we start with that? There's 2 chlorines over here, but only 1 on this side. So what do I need to put in front of sodium chloride? 2. Okay, that gives me 2 sodiums. If I go back over here, there's already 2 sodiums over here. There's how many carbonates? 1. Okay, 1 carbonate here and 1 carbonate here. So it's balanced. 1 calcium, 1 calcium. Looks like that's the only number we need to add. Okay, so when we write that out in words, we have calcium chloride, okay, plus sodium carbonate, okay, gives us calcium carbonate, okay, plus sodium chloride. Okay, so you know how marks would be given out on a question like this. Okay, if I was to give you a question like this on an exam, right, you would get a mark for identifying the reaction correctly, which is probably the easiest mark. You'd get a mark for balancing it correctly, and a mark for writing it out in words correctly. Okay, it would be a 3-mark question. Okay, sometimes I even make it like 4 marks and say you get 1 for the reactants and 1 for the products. Okay, but most of the time I make it you got to get the whole thing right. Right. So do you have to be good at your naming to get that mark? Because even 1 mistake in there costs you the whole mark, right? So we have to make sure that's, if you're still having trouble with naming, you got to come and see me for help because we got to get it straightened out. All right. Okay, last one. HCl plus KOH gives us HOH plus KCl. What kind of reaction is that? It's a double replacement reaction. Okay, so DR. Sorry, we should have wrote DR up here too. Okay, do I need to do any balancing? Yeah. Guys, if there are no subscript numbers, it's balanced because everything is a what? A 1. Okay, and it's already balanced. All right, now, on an exam, if I give you strictly a balancing question, or on an assignment, I give you strictly a balancing question where it's fill in the blank, should you leave it blank? No, write 1s in every blank. Otherwise, I don't know whether you didn't know how to do it or whether you knew how to do it. You have to show me you knew how to do it. Put 1s in every blank. Okay? All right, so this would be hydrogen chloride. Okay, plus potassium hydroxide. Okay, gives us water plus potassium chloride. All right. It's making sense? Okay, once you do a few of these, it gets pretty straightforward. Next week, we'll start looking at being able to predict what the products are. Not right away on Monday, okay, but we'll start looking at that right next week so that you can get the hang of this. Okay, your next quiz is definitely going to have some reaction stuff, identifying and balancing and things like that. Okay. All right, so I'm going to hand out your worksheet on this, and you can get started on that. I would imagine you guys will probably get close to done even in the short period today. All right, so just a couple of instructions here. Number 3 on yours is already done for you, but it isn't done on here. Right, we'll use it as the example. Okay, so is number 8. Okay, so my my modifications have obviously disappeared. I had boxes covering those at one point, but it's all right. Okay, so here's what you guys are going to do. You're going to balance the equations, okay, write in the numbers, and you can see on 1 or 2 of them I missed a number somewhere. Okay, number 5 I missed a number, number 2 I missed a number. Okay, write the word equation and then identify the type. Okay, so those 3 things. Write the word equation means write it out in words. So if we're looking at one of the ones that's done for you there, okay, number 3, because you've seen it a million times already, all right, we would say we have to balance it for, sorry, first identify the reaction. So it's simple decomposition. I write decomp, and then balance it. I've got 2 oxygens over there, 2 here, 2 there. Now it's balanced. Water, okay, goes to hydrogen plus oxygen. Okay, when you write out the word equation, you don't have to put the balancing numbers in the word equation. All right, you only put it in the formula one. Julie, question? Yeah, there's a few numbers on there because what happened was I lost the student version of my worksheet, and all I had left was my key, so I had to scan it and then block off everything. And some of my blocks, I think I must have accidentally pulled the picture a little bit on the file, and so all the blocks weren't blocking everything anymore. That's why some of the numbers show up on there. Okay, so you're welcome. You got a couple freebies. Okay, all right. So get to work on that, guys. Like I say, I don't think that that's gonna take you all that long. You'll probably get it done in class today. Okay, on Monday. And in fact, if we have time today, I'll go over the research project with you, and then on Monday you'll have all of class period in the library to do research. Same with Tuesday, okay? And then it'll be due, a week or 2 from then. I mean, you can as long as work is getting done, okay? But I don't want you going, hey, you do 4, 5, 6, and I'll do 1, 2, 3, and then we'll be done so much faster, because then that defeats the purpose. Yeah. Okay. You want to check and see how you're doing, okay? On my website are the keys to this. Oops, that's not the right one. Okay, so Science 10 Notes and Assignments, Unit 1 Chemistry, and you will see key for all reaction worksheets. Okay, so we click on that. You can check them, see if you did them right. All right, so maybe have a look at those, because I know a few of you are getting kind of close to done there. So just check and see that you've done them right. If you didn't do them right, don't just write down the right answer. Okay, look over what you did and the right answer. If you don't understand why they're different, talk to me, okay? And I will give you a hand and we'll explain. Okay. Okay, there's a mistake on my key. Okay, number 3 here on that last section says 2Al plus 3O2 gives, that's completely wrong. Okay. Oh, I can't write on that. Okay, that should be 4Al plus 3O2 gives 2Al2O3. Right? It's just, I totally screwed that one up. So, sorry about that one. It's all messed up. Okay, so just make sure you make that change. Number 3 on that last section should read 4Al plus 3O2 gives 2Al2O3. Here, I'll write it on this version here. It does? It says what I said? Weird, because I just pulled that off my website. Okay, anyway, in case, whichever version you're looking at there, guys, okay, it should say 4Al plus 3O2 gives Al2O3, and there should be 2 of those. All right, it wasn't swapped and dropped correctly. Okay, it should have read Al2O3. All right, just so you got that one right, we don't practice anything wrong. Listen up here, guys. Okay, I've had a number of people, they've brought their labs in to have me look them over, and a lot of them are saying, Mr. Coder, I don't know how to put this in the right order because I can't put my chart into my Word file. All right, so I'm going to show you here just quickly how you do that. The problem is that a lot of you have done your chart in Excel, and you can't actually paste that chart directly into Word. So here's what you do. Is you build a chart in Word instead, and it's really, really easy to build a table in Word. All right, all you have to do is do this. You put your cursor wherever it is you want to insert the table to. Let's say we want to insert it there. It's not really where it would go, but we'll just say we'll put it there. All right, and you go Insert, and you click on Table here on the little arrow, and it gives you this diagram. So all you do is you count the number of rows and columns that you have on your table in Excel, and go, I need a table that is 6 by, or let's say 8 by 5. Done. All right, and now it is possible to actually take what's in your Excel file, copy it, and stick it in that chart because it'll match up with the number of cells. All right, and if it won't do it, you can just copy and paste each cell individually, and you don't have to recopy the whole thing. All right, so there's how you can put in a chart wherever you want. And if you decide later it isn't where you want it, okay, you can select usually the whole chart as an object like this and just, whoop, come on. It's hard to do on the smart board because I can't quite get the cursor where I want it. But you can drag it around and move it wherever you want it. Okay, so I could take it and put it right there if I wanted to. Okay, so it works pretty slick. If you're needing, if you were wondering how you do that, that is how. All right. Okay, so what we need to do here first, guys, is finish up those reactions from yesterday. So we'll go over those first. All right. So first one, what kind of reaction starts out with an element reacting with an ionic compound to produce a new ionic compound in an element? Single replacement. Okay, so now I have to balance. Iron is 1 and 1 so far. Hydrogen is 1, and there's how many over here? 2. So what needs to go here? 2. All right, when I do that, does that make my chlorines work out? All right, so now everything's balanced. Now I write it out in words. Iron, okay, plus hydrogen chloride. Okay, gives me, now which iron is this? Yeah, it's 2 plus. How do we know that? Well, chlorines minus 1. Okay, that means there's a total of 2 negative charges, so iron has to be plus 2. So this is iron 2 chloride, okay, plus hydrogen. Okay, making sense? All right, so that's what we're going to do. Okay, number 4. Let's have a look at it. So we got calcium reacting with oxygen to make, okay, calcium oxide. So we have to first off balance. So how many oxygens on this side? 2. How many over here? 1. So what do I need to put here? Okay, and when I do that, how many calcium does that give me? All right, is that balanced now? Yeah, everything's out. Okay, what kind of reaction is it? Synthesis. All right, because we're taking 2 elements and forming only one product. Anytime you have only one product, it's got to be a synthesis reaction. All right, and then like we said at the beginning here, it's calcium plus oxygen. Okay, gives us calcium oxide. Okay, any others? You're not going to just make me do them all, right? Okay. All right, so number 5. Okay, so we got aluminum. And we've got oxygen, and we're getting aluminum oxide out of this. Now, one of the numbers showed up here, so that gives you a bit of a tip toward the balancing. 2 times 2 is how many aluminums? 4, so what needs to go here? All right, and for the oxygen, 2 times 3 is 6, so what needs to go here? A 3. All right, so we got 4, 3, 2, and then we just write in, okay, this is aluminum plus oxygen, gives us aluminum oxide. And what kind of reaction is it? Synthesis. Yep. Okay. All right. Keep her going there, guys. Okay, just want to go over number 9 here. Tricky balancing thing, and this is going to come up because it also comes up on the first page with a couple of them. All right, just so you're aware here. Sometimes you have to just make numbers really big to get it balanced, and then you can look at the numbers and go, oh, well, I can divide all of those by this number and reduce them down, right? Number 9 is a prime example of that, all right? On this side, on the reactant side of number 9, I have how many oxygens? 3. And on this side, I have 2. Lowest common multiple of 2 and 3 is 6. All right? So if I start out trying to make 6, I put a 3 here. But when I come back over here, that creates a problem. There's no way I can balance this number or this equation with a, well, there may be, okay, over here. So I've got 3 times 2 is 6, and over here I've got 3 times 1 is 3. Okay? Is this going to work for me? No. All right. So we got to go back, okay, and try this again. Try something maybe a little bit bigger. All right. So here's what I've got to do. I'm going to try putting maybe a 4 here. Okay. Go instead of from 6, go to 12. All right. So sorry, 4 times. Sorry, not to 12. 8. Okay. 4 times 2 is 8. Okay. So I got to put a 4 here. Everybody with me? All right. That gives me 4 oxygens there. I have 8 on this side. What needs to go here? 2. Okay, 4, 2, 4. Haley, I showed you the wrong. I had it in my head wrong when we did this. Okay, all right, 4, 2, 4. Can I reduce that? Yeah, to what? 2, 1, 2. All right, so then I can go back down. Okay, 2, 1, 2. So sometimes you just have to experiment a little bit, okay, with an equation until you get it right. Okay, and you go back and forth a bit. All right. What kind of reaction is that? It's a tricky one too. It's actually a synthesis, but it's a complex synthesis because it's a compound and an element forming a single compound. All right, you wouldn't get one that didn't fit the mold on a test or a quiz. Okay, but that's a complex synthesis. Let's have a look at number 11. A lot of people asking about 11 here. Okay, it's just a balancing thing. Obviously, it's a decomposition reaction. It's a complex decomposition, but it's decomposition. All right, people are just struggling to balance it correctly. I've got 3 oxygens on this side, and I've got 2 over here. Okay, so again, we've got that low multiple thing. But we can start out trying that, or I'm going to just. Sometimes you can just start out with trial and error. Right? If it doesn't work with 1 as the first number here, what should you try next? 2. All right, so let's try 2 here, and then just see how it goes. All right, so that gives me 2 nitrogens, so what do I need to put here? A 2. All right, if I do that, now on this side, how many oxygen do I have? 4. And on this side, I have 2 times 1 is 2, plus 2 more is 4. Hey, how about that? All right. The other way you might have done that is you might have said, okay, lowest common multiple is 6. You tried to make it 6 and it didn't work. So you went, okay, I'll try 12, right? And so you put, you know, like a 6 here and you kind of work with it. Essentially, you just kind of keep going up with a different number on the first one, and you don't usually have to go very high before it works. Okay? Okay, numbers got cut off on 13. That should be H2S O2, H2O, and this is the S8 worked out, so it's S8 on that side. Okay, guys, I don't know what happened with my key here. I must have been up very, very late when I did the last little bit here. But number 1 and number 3 on the key online are wrong. Okay, for some reason it says for magnesium and chlorine, it says Mg plus 2Cl gives MgCl2. Well, is chlorine one of our special ones? Yeah, so it comes as a 2 on its own. Okay, so it should look like that. Chlorine is one of the molecular elements. Okay, and number 3 on the key is also wrong because the swap and drop on aluminum oxide is wrong. Okay, so when you look at that one, it should look like this. It should say 4Al plus 3O2 gives 2Al2O3. Right? So both of those are wrong on the key. Sorry about that.